So now that we've learned how to find a greatest common factor, we're going to use this idea repeatedly to factor by grouping. Now, once upon a time I didn't love factor by grouping, and to be honest, you can factor however you want. However, on any sort of problem you can factor any way that works for you. However, factoring by grouping is the only way to factor one certain type of problem. But what's nice is you can actually apply it to all factoring problems. So that's what I like. I like a one-size-fits-all approach. So hopefully you'll embrace factoring by grouping, not only for when you have to factor by grouping, but when you're just factoring in general. But again, the choice is yours. So finding a greatest common factor. What we do is we see what each term shares in common. These are both multiples of x, so we can pull out that x. Then if you think of factoring as sort of the reverse of the distributive property, if you think about it, x times 3a makes 3ax, and x times negative 7b makes negative 7bx. But so that's our factored form of our first example. We have the greatest common factor. So some questions you might just be asked, what is the greatest common factor? In this case, it's x. That's the biggest number that both terms are a multiple of. They're both multiples of x. But if they ask you to write it out in fully factored form, there is our final answer. All right? So finding a greatest common factor is very, very important. So here's something that's interesting, and this is sort of building us up to our factoring by grouping experience here. Notice how, just like both of these terms were a multiple of x, that was the greatest common factor, both of these terms are multiples of 2a plus 5b. So what we'll do is we'll factor that out front, just like we factored the x out front. Then if you think about the distributive property, if we factor that out front, we first have 2a plus 5b multiplied by 3a. That's this entire first term. And then we have 2a plus 5b multiplied by negative 7b. That's this entire second term. So that's our fully factored answer. And so it's interesting. You could have a binomial like 2a plus 5b, or you could have a monomial like x as your greatest common factor. And I don't want that to spook you. So one thing that's really important, and this is going to be helpful in terms of checking your work as we go forward and factor, if someone asked you to multiply two binomials, you could be so interesting as to distribute the first term you could be willing to distribute the greatest common factor to the first term and the greatest common factor to the second term. Usually you think of it as we'll multiply 2a times 5b and 2, and we'll multiply 3 by 5b and 2. But now you can really distribute the whole greatest common factor to both, and then you can distribute and clean up. So that's an important thing to think about so that you can understand that it's okay to have a greatest common factor that is a binomial. You can also check your answers. If, let's say, this was your answer to a factoring problem, you could multiply it all out and get back to the original, and then you'll understand that you factored it successfully. You just changed the way it looks. You did not change its value. So normally, the question will look like 10ab plus 15a plus 15b plus 4a plus 6, and we will find the greatest common factor of the first two terms and the second two terms. That'll bring us here, and then we will write out our final answer like so. So the reverse of the example is what we're going to do quite a lot. So as you can see, I like to kind of draw it like this. When we're factoring by grouping, we will factor groups. We'll look at the left-hand group and the right-hand group. And we ask ourselves, what is the greatest common factor of the left-hand side? These are both, 10 and 15 are both multiples of 5. A, B, and B are both multiples of B, so we pull that out. Similarly, we've got our greatest common factor on the right-hand side of 2, and then we just pull out our greatest common factor, and that's our final answer. So that's the action, the fundamental action of factoring by grouping. Now what we're going to do is we're going to factor each of these examples by grouping. Notice how in questions 1 through 4, they each have 4 distinct terms. If you see a problem like this where you have 4 different terms that cannot be combined, you have to factor by grouping. There's no other way to do it. Okay, so let's get right into it. On this first example, what we're going to do is we're going to set this up in terms of 2 groups. We'll ask ourselves, what is the greatest common factor of 5xy and negative 8x? They're both multiples of x. And so x times 5y, that makes our first term of 5xy. And x times a negative 8 makes our negative 8x. Okay, so we found the greatest common factor of the first 2 terms. Now the second 2 terms, I notice here we have a negative coefficient of this third term, so that makes me think that it's going to be in our best interest to factor out a negative. So if you think of 10 and 16, they're both multiples of 2. That's their greatest common factor. But instead I'm going to pull out a negative 2. And here's why. Think about it, negative 2 times 5y, that makes a negative 10y, and a negative times a negative, negative 2 times negative 8, that makes positive 16. Now, why did I bother to do that? Well, I needed the greatest common factor to be the same on both of them, and now it is, so we can factor that out. And the leftovers of x and minus 2 can be multiplied right afterward, and that is our final answer. So you have to have that inspiration. If that third term is negative, you're going to want to factor out a negative sign, and that's going to come up repeatedly. And what you could do is you could multiply this out, distribute it, or however you want. If you multiply it all out, you should get back to the original, and that will show you that you are, in fact, correct. You did it correctly. On our second example, let's factor it by grouping. First 2 terms, 12ab and negative 14a. Well, number-wise, they're both multiples of 2. That's their greatest common factor. But they're also multiples of a. So that's our greatest common factor. 2 times 6 is 12, and a times b is ab. 2a multiplied by negative 7 makes our negative 14a. So see how I'm always like double checking as I go? That's really, really important. Now here's that rule again. If the third term is negative, pull out a negative. Now if you think of negative 6b and 7, they share nothing in common. They're both just multiples of 1. But since we have a negative as the third term, let's factor out a negative 1. And then magically, this is all going to be just fine. If you think about it, negative 1 times a positive 6b makes a negative 6b, and negative 1 times a negative 7, negative times a negative, makes a positive. Oh, look, we have our greatest common factors. We'll pull that out. And then we'll write the leftover. And we have successfully, again, factored by grouping. All right, so here's our third example. Factoring by grouping, we have 4 separate terms. We'll look at the first 2 terms. And the greatest common factor of 6 and 9 is 3. Of x squared and xy is x. So we'll pull out a 3x. And 3x times 3y, that makes 9xy. And, oh, again, our third term is negative, so rather than just pulling out a 7, we will pull out a negative 7. And x and y share nothing in common, so this is our greatest common factor. Negative 7 times 2x, that's negative 14x, and negative 7 times positive 3y makes a negative 21y, and we're really happy because the greatest common factor is the same. We can factor that out from the two terms, and 3x was multiplied by 2x plus 3y, and negative 7 was also multiplied by 2x plus 3y, and that's our final answer. Our fourth example, we'll do the same thing. 6 and negative 15, those are both multiples of 3. X cubed and x squared. So x cubed is x times x times x. X squared is x times x. So they share 2 x's multiplied together at most. And 3 times 2 is 6. X squared, 2 x's multiplied together, and a third will make 3x. 3 times negative 5 makes negative 15. We already have our x squared there, so we don't need anything else. And this is also a great example. Notice how the third term is not negative, but 2x and negative 5, they share nothing in common but 1. That's okay. Our greatest common factor is 1. Don't let that weird you out. 1 times 2x is 2x, and 1 times negative 5 is negative 5. So we have 3x squared plus 1 times 2x minus 5. And that's our final answer. Okay, so I'm going to rip through the last 3 factor by groupings kind of quickly. Still apply the same process, though. Group the first 2 terms and the second 2 terms. Ask yourself, what's the biggest number that 4 and 21 share in common? Nothing. A squared, oh, actually, I'm not going to rip through this one because it's going to be kind of interesting. A squared and b to the third, they share nothing in common. So what I might try to do is I might try to rearrange things. I'll keep my 4a squared. Maybe I'll move over the 6ab. And this is totally acceptable. And then I'll move over my 21b to the third minus 14ab squared. So all I did was kind of switch up the ordering. And now if I group, the left 2 terms will share some things in common finally, and the right 2 terms will share some things in common, so then this should work out fine. So sometimes you might have to rearrange things. I basically just moved these 2 terms around. Now, the first 2 terms are multiples of 2a. The second 2 terms, since that's a negative, they're both multiples of negative 7, b to the second. And then we'll just fill in the leftovers. 2a times 2a makes 4a squared, and 2a times 3b makes 6a times b. Negative 7b squared times 3b makes negative 21b cubed, and negative 7 times positive 2 makes 14b squared, and we have to multiply by a. Ooh, voila! 2a plus 3b and 2a plus 3b, that's our greatest common factor. That's the world's worst 3. So we have 2a plus 3b, our greatest common factor. And we would distribute that and multiply it by, we would distribute it to the 2a and the negative 7b squared. And that's our final answer. So sometimes you may have to move things around. So I might star this one because it's a little bit more special than the others. So on this next problem, I can tell right away that we're going to have to move things around. If we, oh, no, actually, I don't think we have to. 7 and y, their greatest common factor is 1. So 1 times 7 plus y, that makes 7 plus y for sure. And the second 2 terms, they are both multiples of negative 3x. and negative 3x times a positive y makes negative 3xy, and negative 3x times a positive 7 makes a negative 21x. And notice y plus 7 is the same thing as 7 plus y, just like in the last example. So we have our greatest common factor, 7 plus y, and then we'll just pick up the leftovers. That's our final answer, factoring by grouping. And again, you could multiply it out, and you would get back to the original so that you know that you did it correctly. And our last example. So this one's kind of funny, but let's just go for it, and then we'll see what's funny about it. Okay, first two terms are multiples of 4y. Second two terms are multiples of 5. 5 times 3 is 15. Oh, look at this. There's no x terms here, so this is kind of falling apart. So that goes to show you that we can't factor by grouping here as is. Let's just try and move things around and see what happens here. Let's say we had 8xy minus 10 and negative 12y plus 15. Let's try and rearrange things and see what happens. Let's group the first two terms. They're both multiples of 2. Then we have 4xy minus 5. Over here, both multiples of 5. And then we have, I'm sorry, both multiples of, 3. We have 4y plus 5. I'm sorry, minus 5. Now look, those again are not the same. So what I think we're seeing here, ladies and gentlemen, is sometimes factoring by grouping might not work, and really we should probably combine those two terms. And we will find that, sadly, I don't believe that we can factor this, folks. Just don't think it's going to work. So it is what it is. Not every problem is going to be factoring by grouping. Notice how this didn't have 4 distinct terms, and we couldn't kind of split things up and make them work. And that's okay.